Hi guys, today we'll be talking about how to find correlation. Okay, so I love this website. It's a great, wonderful website. We're going to talk about it. It is mathisfun.com. Okay, so let me zoom out a little bit so you guys can see it. Alright, when two sets of data are strongly linked together, we say they have a high correlation. The word correlation is made of code, meaning together, and relation. Okay. Correlation is positive when the values increase together. In other words, the explanatory and the response variables. And correlation is negative when one value decreases as the other increases. So as the explanatory increases, the response decreases. So here's some examples of pictures of what it's going to look like. Okay, NOR correlation is going to have a number of 0 and it's going to look kind of scattered in here. Low positive and low negative correlations are going to be around 0.3 and negative 0.3. High positive correlations are going to be about the 0.8 to negative 0.8 range. And perfect positive correlation, which is not realistic, is going to be about the negative 1 to 1 range. Okay. Alright, 1 is a perfect positive, 0 is known, negative 1 is a perfect negative. Okay, the value shows how good the correlation is, not how steep the line is. So that's important to remember. And if it is positive or negative. So for example, ice cream sales. The local ice cream truck keeps track of how much ice cream they sell versus the temperature on that day. Here are the figures for the last 12 days. So, and remember, this is in Celsius. So you're going to have to do some conversions for Fahrenheit if you'd like. Just know that this is about 80 degrees maybe. Okay, so it's really interesting. All right, and here's the same data in the scatter plot. So as you can see, it looks pretty strong, but what is the exact correlation? The exact correlation is 0.9575. Okay, and this is a linear linear regression type of plot. Okay, so this would be a good idea to use a linear regression. Correlation is not good at curves. The correlation calculation only works well for relationships that follow a straight line. Our ice cream example, there's been a heat wave. It gets so hot that people aren't going near the shop and sales start dropping. So now it goes up, 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 and then all of a sudden it gets so hot no one wants to buy any ice cream. And if you think about it, okay, this correlation would be 0. Like, oh my gosh, there's no correlation between it. Well, if you think about it, the explanation for this data is that it's so hot no one wants to go outside because that's ridiculous. Okay? Right? More of the story. Make a scatter plot and look at it. You may see more than correlation values say. So don't ever look at R and say, oh, that's it. Alright, now here, correlation is not causation, as I just proved with this story. Correlation is not causation, which says that there's correlation does not mean that one thing causes the other. There could be other reasons that the data has good correlation. Example, sunglasses versus ice cream. Our ice cream shop finds out how many sunglasses were sold at a big store for each day and compares them to ice cream sales. And look, oh, there's a strong positive correlation. Does that mean that sunglasses make people want ice cream? Okay? No, it doesn't, just in case you're wondering. Okay, now let's say you didn't know how to calculate the correlation coefficient. Now, if you were in the calculator, you would go to stat and you would just punch it in and just work with it. Okay, now here's one in actual Excel. I haven't tried this out, so don't ask me about it, but here's some stuff you can do. All right, Pearson's correlation, there's software to calculate it, such as Corel parentheses, so you could use this on Excel, a function in Excel or OpenOffice's calculator. But here's how to calculate it yourself. Okay, so let me zoom out a little bit so you can see everything. Okay, let's call the two sets of data X and Y. In our case, temperature is X and ice cream sales is Y. So this is the explanatory and this is the response. So that makes sense why temperature explains ice cream. All right, find the mean of X and Y. Step 2, subtract the mean of X from every X value, call that A, and do the same for Y, call that B. All right, step 3, calculate A times B, A squared and B squared for every value. Okay, sum up the A times B, sum up the A squared, and sum up the B squared, and then divide the sum of A times B by the square root of the parentheses, sum of a squared times the sum of b squared, parentheses. Okay, so here's how I calculate the first ice cream example. Values rounded to 1 or 0 decimal places. Okay, so here's the temperature. This would be the x, this would be the y. Okay, all right, so I found the mean. First off, you would find the mean of the temperature, and then you would subtract it and get this column. You would find the mean of the sales, subtract it from this column and get this column. Then you would times it for each one, so negative 4.5 times negative 187, and you just times them across just as you go, la la la. Okay, and then you would square this one, each one of those. So this is 4.5 squared, this is 2.3 squared, this is 6.8 squared, this is negative 3.5 squared, and just so on and so on. Okay, and so it goes all the way down. Same thing for b squared. Okay, so we have everything all set up. Now we're going to add up all these, and add up all these, and then it's going to be a times b, which is this, divided by the square root of a squared, which is 177, times 174,757, which gives us the correlation of 0.9575. This is the formula. You do not need to know how to use it. You just need to be able to get your own correlation coefficients. If you're using the TI-85 given in the first lesson of the unit, that's probably going to be the most helpful. Okay, sigma is the sum of, we've already seen those, x minus x bar is each x value minus the mean. So remember, x bar is mean. Same thing with this, except this is going to be y bar, which is the mean of y. Okay, you probably won't have to calculate like that, but at least you know it's not magic, but simply a routine set of calculations. Okay, all right, so programmers, this is what you need to know as well. There are other ways to calculate the correlation coefficient, such as Spearman's rank correlation coefficient, but this one is probably the best. What was the exact name? I always forget what the exact name is. Let me see. Pearson's correlation. I always wanted to say that. Okay, so while you guys are taking a look at that, just please understand correlation. You want to be able to calculate it. You want to be able to work with it. Find a calculator that works for you to find correlation and use it always. Okay? Thank you very much and have a great day. Bye.